How does melting point relate to freezing? Have you ever wondered how melting and freezing are connected? These two processes might seem different, but they actually share a special relationship. Let's break it down in a simple way. The melting point and freezing point of a substance are the same temperature. When a solid turns into a liquid, we call this melting. Conversely, when a liquid becomes a solid, we refer to it as freezing. At this specific temperature, both solid and liquid forms exist together in a state of balance. This balance happens because the energy levels of both phases are equal. From a thermodynamic perspective, at the melting and freezing point, the change in Gibbs free energy is zero. This means that neither the solid nor the liquid phase is preferred energetically. However, during melting, the heat content, known as enthalpy, increases. At the same time, the disorder or entropy of the substance also rises. To change a solid into a liquid at this temperature without altering the temperature itself, we need to add energy. This energy is called latent heat or heat of fusion. It breaks the orderly structure of the solid, allowing the molecules to move freely in the liquid state. Pressure plays a role in how melting and freezing points behave. For most substances, the solid form is denser than the liquid. This means that increasing pressure raises the melting and freezing point. Water is an interesting exception. Ice, which is the solid form of water, is less dense than liquid water. So, when pressure increases, it actually lowers the melting point of ice. In phase diagrams, the lines for melting and freezing overlap. This overlap shows the temperature where solid and liquid phases coexist. While the temperature remains the same, the direction of heat flow differs. Freezing releases latent heat as the liquid solidifies, while melting absorbs heat as the solid turns into a liquid. Understanding this relationship helps explain why adding salt to water lowers its freezing point. This phenomenon, known as freezing point depression, allows ice to melt even when temperatures drop below 0 degrees Celsius. This principle is particularly useful for de-icing roads in winter. In summary, melting point and freezing point describe the same temperature where solid and liquid phases balance out. This balance is influenced by thermodynamic principles, including Gibbs free energy, enthalpy, entropy, and pressure. The fascinating interplay of these factors shapes our everyday experiences with freezing and melting.